Good evening and welcome to the Q&A session 21 from the chapter of moving charges and magnetism. The topic is the comparison of magnetic field at two different points due to a current carrying conductor. So I have framed one question which is based on this topic, and the question here is: a long cylindrical conductor of radius capital R carries a uniform current I. So the ratio of magnetic field at 2 points at a distance of r by 2 and 2r from the axis of the conductor is. We have 4 options here and we have to find the correct option. So I have already drawn here one this cylindrical conductor whose radius is capital R, and now there are 2 points here. So one of the point is at a distance of r by 2 from the axis of this conductor. So let us say this is the point. Let us say this point is P. So its distance from this from the axis of this conductor is r by 2. And there is another point which is at a distance of 2r from the axis of the conductor. So 2r means this point will be outside the conductor. Let us say this is the point Q. So its distance, that is this distance, this is equal to 2r. The distance of this point Q from the axis of this conductor is equal to 2r. So in the session number 18, we have derived the equation for the magnetic field at the point inside the current carrying conductor, and in the session number 19, we have derived the equation for the magnetic field at a point which is lying outside the this current carrying conductor. So for the point which is lying inside the current carrying conductor, the magnetic field B was equal to mu naught I R divided by 2 pi R square. Here R, small r, is the radial distance of the point from the axis of the conductor, and capital R is the radius of the cylindrical conductor. So from this equation, the magnetic field at this point P, I am just denoting it as BP. This will be equal to mu naught I, and here small r will be replaced by r by 2. So r by 2, this 2 will come in the denominator, multiplied by 2 pi r square. So from here this r and r will get cancelled out, and finally the magnetic field at this point P, which is lying inside the current carrying conductor, and here the current which is flowing in this conductor is uniform. So the magnetic field at this point P, which is at a distance of r by 2 from the axis of this conductor, and because it is at a distance of r by 2, it is lying inside the conductor. So we have used the formula for the magnetic field at a point inside the current carrying conductor. So we have derived the equation for the same in the session number 18. So this is equal to mu naught I divided by 4 pi r. Now for this point Q, which is at a distance of 2r from the axis of the conductor, so this point is lying outside this current carrying conductor. So the magnetic field, the formula for the magnetic field at a point due to a current carrying conductor, and if the point is lying outside the conductor, then in that case the formula is equal to mu naught I upon 2 pi r. So I am just denoting the magnetic field at the point Q as BQ. So this will be equal to mu naught I, and here this r is equal to 2r. So this will be equal to, I will replace this r by 2r, so I will be getting the answer as 2 pi into 2r, that is equal to 4 pi r. So from these two values, that is the magnetic field at the point P is equal to mu naught I upon 4 pi r, and the magnetic field at the point Q, which is outside the current carrying conductor, this is also equal to mu naught I upon 4 pi r. So since both these two values are equal, so we can say that the ratio of the magnetic field at the 2 points at a distance of r by 2 and 2r from the axis of the conductor, this will be equal to 1:1. So thank you very much for joining this session. In the next session, we will be continuing with the same topic of this magnetic field, But the question for the next session will be entirely different from what we have done today. So till then, have a nice day. Bye.